Let's look at sample problem 9.1 where we are identifying acids and bases, and specifically Bronsted-Lowry acids and bases. So we have two reactions here, and in each equation identify the reactant that is the acid or the proton donor and the reactant that is the base or the proton acceptor. So looking at A, we want to remember that the proton donor or the acid is going to be the one who from left to right loses a hydrogen and becomes more negative in its charge because it's lost that H+. So both of our molecules are neutral on the left or no charge, and if I look at nitric acid on the left and on the right I have nitrate, it has lost its proton. There is one less hydrogen in the formula and the charge is more negative. So the proton donor is nitric acid. And if I look at water, the base or the proton acceptor from left to right is going to gain a hydrogen and its charge is going to become more positive. So on the left hand side I see water, H2O, and on the right hand side H3O+. It has gained a proton and its charge is more positive. So water is acting as a base here. Let's look at B. I see hypochlorite, the anion, reacting with water. Hypochlorite cannot be a proton donor because there's no hydrogen here. The proton donor has to be water. And if I look from left to right, I see that water loses a hydrogen and its charge becomes more negative. So water on the left and then hydroxide on the right. If I look at perchlorate, it gains a hydrogen and its charge becomes more positive. So hypochlorite is the base or the proton acceptor. It gains a proton, and water is my acid or proton donor. It loses a proton.